Hi students, I wanted to review modular division real quickly because there seems to be a little bit of confusion on this, and I wanted to make a video so that it's nice in one little spot so you don't have to go digging through any of the previous Zoomcasts. So these division problems, it's important to understand that the division problems all have related multiplication problems. The reason I bring that up, of course, is that when I'm trying to figure out a way to solve these problems, try to think of the related multiplication problem. That is to say, if 7 divided by 4 equals, well, something, then that something times 4 must get you back to 7. Hopefully, you've done some work with division and multiplication fact families in your elementary school careers. For instance, 20 divided by 4 equals 5. That's because we know 4 times 5 equals 20. I can use that same knowledge to inform my answering process here for 7 divided by 4. And in this case, I chose mod 9. It was arbitrary. So as you're going to try to solve this, here's your method. Rather than sitting there guessing and checking, and that's why I have some students saying, oh, I just guess and check. No, actually you don't. Because we know our result is going to wind up with something in mod 7. I'm going to start looking in mod 7 for numbers that are equivalent. So that is numbers that are equivalent in mod 9, I mean to say, to 7. So obviously I'm going to start off with 7. So to find the next numbers in sequence, all I really need to do is just start adding this mod number here, this plus 9. I'm just going to add 9 and create a nice little sequence. So each of my numbers is going to be exactly 9 units apart. So when I do 7 plus 9, I get 16, plus another 9 is 25, plus another 9 is 34, and 43, and so forth. Now, I don't really need to keep on going forever and ever, because the truth is, all I really need to do with this is stop the second I find a multiple of 4. In this case, why multiple of 4? Because that's what I said I was multiplying by. So that's what we're going to look for. Look for a multiple of 4. And we have one right here. So indeed, this answer winds up being just 4. So when you look at it, 4 times 4, of course, is 16. But 16 taken at mod 9, obviously, is 7. If you're going down the sequence here, if you happen to miss that 16, you will eventually hit something else that is also a multiple of 4. But hopefully you look at this and say, wait a second, that's 4 times 13. Notice 13 is not actually a viable answer here because 13 is not an element of mod 9. Yeah, mod 9 sets just 0 through 8. If any answer over 8 is invalid, so I can just ignore that. Bottom line, 7 divided by 4 is 4. Let's try 5 divided by 2. Again, we know that equals some mystery number, and that therefore 2 times that mystery number must be equal to 5 in model 11. So again, I will start listing numbers here, obviously starting with 5. And in this case, my sequence, I just need to add 11 to make my list. 5 plus 11 is 16. That makes 27. Add another one, that's 38. And indeed, here we are on this one. Here I've got the 16. Which of course is obviously a multiple of 2. That's really all I needed here. I just had to look for a multiple of 2, and I found it. 2 times 8 makes the 16. See the relationship here? So yeah, that's going to do it. Now, of course, again, you may say, hey, 38 is a multiple of 2. Yeah, but it's 2 times 19. 19's too big. So one more example. How about 7 divided by 3 equals, well, some blank. We don't know what that is. But again, we can write the related multiplication problem. Hopefully that helps. 3 times in mod 13. That blank equals 7. So again, I'm just starting with 7. And I'll just add 13 until I find some multiple of 3. So again, we're going to look for multiples of 3. So in this case, if I'm taking a look at this, 7 plus 13 is going to be 20, okay. 20 plus 13 is 33. I think I found my multiple of 3. It's going to be 3 times 11 gets me to 33. So I'm going to write 11 in the box, which I know this works because it is an element of mod 13. Sometimes you're going to get strange answers, strange situations, I mean to say, especially when you're using some kind of modulus that's not a prime. So, for example, if I ask you to do, let's say, I'll do 4. Let's say 4 divided by 3, and we'll say it's mod 12 this time. Okay, so now I'm looking for multiples of 3. Let's see, mod 12 equal to 4. Okay, so I'm starting with 4, and now I'm just going to start adding 12, and we're looking for multiples of 3 into my list. But there's a problem here. This should jump off the page at you, because when I'm adding 12, that's an even number, to another even number, I'm guaranteed to have just a list of even numbers. I'll never get a multiple of 3, so instead of exclamation point, it becomes more like question mark. This has no solution. So there is no solution for this. Does that make sense? I hope. By the same token, this mod also could generate multiple answers. This mod 12, if I say 2 times square equals 6, it's almost immediate. Students say, oh, I know the answer is 3, but wait, before you write a 3 down, again, let's see, and of course this would have been 6 divided by 2. I'm sorry, I kind of got ahead of myself here. If I was trying to add 6 divided by, if I was trying to solve 6 divided by 2 in mod 12, yeah. All right, so again, like I said, people look at this and they say 3 and they walk away. But indeed, this one, if I start adding 12 on here to each number, oops, why did I write a, sorry about that, I messed up, I wrote a 3. All right, sorry, let's try this again. All right, 6, blank, 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 blank. I'm adding 12, adding 12, adding 12. Again, now, like I said, I'm sure most of you are looking at this and say, wait, there's my answer, because this is going to be some multiple of 2. Because remember, we're looking for multiples of 2. Excellent. So, when I add 12 to this, I get 18, which again, that's also a multiple of 2. Yeah, so this one and this one. So I wind up with 3 and 9. If I add 12 to this, you get if it's 12 to 18, I get 30. Now, 30, I'm not going to include that one because that would be 15. 15 times 2, so that's just too big. But in this case, again, I've got 2 solutions here, but on one like this, I had no solution. The key is on those is that whenever you have a mod number, that's this number here, in this case these last 2 I did 12, and I did 12 by design. Because when that mod number is not a prime number, you could get no solution and you might get multiple solutions. You might still get one solution, but you're going to learn in the coming days that whenever our modulus is a prime number, like I used on those, but not necessarily this one, 9's not a prime, but 11, 13, I did those because I was guaranteed to have exactly one solution. I hope that helps. Please take a look at this and try to understand this with respect to those division questions here in Chapter 1.